welcome everybody. Welcome to our virtual gathering presented by the New Hampshire Preservation Alliance. We are the statewide membership-based historic preservation organization. My name is Beverly Thomas, and on behalf of the New Hampshire Preservation Alliance, I'm pleased to welcome you to A Tale of Old and New, Outfitting Your Old Houses and Barns with Solar Technology, with Eric St. Pierre from Revision Energy. This program is the fourth in our series of Old House and Barn Expo on the Road. As many of you know, because of COVID, we've replaced our popular biennial Old House and Barn Expo with a series of virtual programs throughout 2021, and some in-person events we'll be hosting later in the year. We love getting you and other Old House and Barn owners and enthusiasts together and to share practical information from highly qualified presenters, make connections, and offer you a dose of inspiration and energy too. Many thanks to our sponsors for making these programs possible, and to all of you who are supporters of our critical work that helps to advance efforts to save and steward special places around New Hampshire. A few housekeeping points I'd like to mention before we get started. We are recording this session today, so please stay muted to keep the background noise to a minimum. You may also want to spotlight the host during his presentation by choosing the side-by-side speaker option under your view feature, usually top right-hand side of your screen. Eric's presentation will be about 45 minutes and will be followed by a 15-minute Q&A. I'll wrap up the program by 1 o'clock, but Eric has agreed to stay on for an additional 15 minutes if we have additional questions. So please feel free to stay on until about 1:15 if you'd like. Because of our numbers today, we encourage you to use the chat feature at the bottom of your screen. Too many people to be able to just ask a question. And before we close today, we will select a lucky winner of our door prize at the end of the program. And now I'm pleased to introduce our speaker. Eric St. Pierre spent 2 decades in the construction and carpentry trades before joining Revision Energy as a solar design specialist 7 years ago. He uses his knowledge of the home and building trades to help homeowners learn more about ways they can reduce energy usage, improve comfort, and make the transition to a cleaner future. So at this time, I'll turn it over to Eric. Thank you very much, Eric.
Thank you, Beverly. And thank you everybody for showing up today. It's a real pleasure to chat to this group. I'm looking forward to this, and hopefully bringing some new knowledge to those who are interested, maybe some questions that I can help to answer, but really just like to go through this and kind of show everything here for this group. So commonly do these type of education type presentations. But what I've tried to do here is tailor it a little bit more to this group. And I think for myself, as Beverly noted, I have a history here in the carpentry trades. And so this is really a nice, comfortable place for me. I'm familiar with talking about the older home. Truth be told, I've spent probably more time than I'd like to admit down in the old basements, replacing rim joists, jacking up and leveling the old homes, and going through replacing windows, doors, siding, and all these old homes. So I'm just very, very familiar with it. But looking forward to chatting, looking forward to any questions that come about. So don't hesitate to throw anything in that chat. But we'll get right into it here. And we'll start with revision in and of itself. Why revision? Why listen to what we have to say? We've become now, and this is in my time here, again, 7 years with the company, started as 60 employees company-wide. We're now really 300 employee owners. So becoming an employee-owned entity over time, really awesome for me as I meet with customers far and wide across the state here. Being an employee-owned company really helps because, that's our quality control baked in. When you're an owner and you have shared equity stake of a business like this, you really, really focus in every day on what that result is, what that customer's experience is like. So for us, it just really, really helps bring that comfort, bring that trust to the homeowner, especially in this case where we're going to talk with those who have an older home, an older barn, and they want to preserve that. That's a huge piece that we want to pay attention to in this. So again, being an employee-owned company really helps us strive for that and keep that in check. Additionally, we became a certified B Corporation a few years back. And if for those who aren't familiar with a B Corporation, the B stands for Benefit Corporation. And it's an evaluation that a business can go through to show that, on the financial side of things or on the profit side of things, we're not just worried about profit here. We're actually using this business as a platform for good. And what do I mean by that, right? We get evaluated to be to show proof that not only are profits an important thing to be a sustainable business here, but we are looking to do things that are better for the planet and better for society. So really the triple bottom line that we always talk about is people, profit, and planet. And that's what it means to be a certified B Corp. So again, just revision as a company, those are the kind of things that we fall back on. It's what we use as our guiding stars. We're making decisions on, what the future of revision looks like and how we're going to best help our clients. And really with that, our mission here, right? So, again, looking at this and saying, hey, we've got, in our case, in this conversation, the old home, the old barn, we want to preserve that. We want to keep that going on into the future. Well, not only the old home and the old barn, but the environment in general. We want to preserve it. So how can we blend this all? So, the mission that we always go back to is that the fact that we're going to lead our community in solving the environmental problems caused by fossil fuels while alleviating an economic and social injustice. So it's a lot there, but that when we come back to making the big decisions, when we come back to saying how best can we serve our customers, that's the mission. That's what guides us, right? So really cool stuff. Now, why would that be our mission? Well, the reality is this is a picture here of Mexico City. It's just one of those that when you put it up, you just go, wow, look at the density. Look at the amount of people that live per square foot here. And with the reality of being 7.5 billion people on this planet now, and the trajectory showing that we should be 10 billion by the time we hit 2050, the reality is the problems that we're creating from the emission of carbon right now is something that we've got to do something about it. And it's just the importance is there. So, an image like this, looking at the fact as well that, there are over 250, almost 300 million cars on the road here alone in the US. And the data shows us that for every gallon of gasoline we burn in those cars, we're going to emit 24 pounds of carbon pollution into the air. We've got to do something. We've got to transition away, really. So again, that's what gets us towards solar. And, when we start to look at the Northeast here, one of the big questions that we start to see all the time is, well, Eric, solar sounds great. All of this stuff sounds great, but do we get enough sun in our region? And you start looking at it and you start to compare. You go, well, we're not California, we're not Arizona. But if you talk to anybody and you said, hey, what do you think about the French Riviera? They get sun, right? Well, if we look, we share a latitude. Right here on the slide, I have it marked as Maine, but we're a Maine-based company. It's where we originated from. We operate in Massachusetts and New Hampshire and Vermont as well. But for this purpose here, you can really see that if we look at that global map, in all reality, the French Riviera receives as much sun as we do here. So when we start looking at solar as a potential, it's there. We can really harness the sun that we have available to us to make some clean energy and to use it to our benefit, right? So how does that all work? Well, as we know, and most of us know now, we start to see this more and more and more as solar panels are prevalent now. They're out there, not to the degree that I think they should be, but they're there. And how do they work, right? So those solar panels, they sit out on a roof, on the ground, wherever we can, find a sunny location to use them. As that sun hits the panel, it starts to create DC electricity. DC electricity works wonderful in our cars and batteries, but not so in our home. So what's to happen is we need to use another item. That item is called an inverter. You'll see that on the next slide. I'll have a better visual for you there. But that converts it into usable energy. Now, from there, that's a simple process, but how does it really work here in the Northeast? How does it work with the utility? How does it work in regards to when the sun's not shining? Well, we have a meter on the side of the house, and the relationship that we have with the utility is called net metering. Simply put, what can happen is during a sunny day, we're going to have an overload of that energy coming through our inverter, going into the home, and any excess that we're not using goes back out to the grid and really services our neighbors in real time. But what happens is because it passes through our meter, the utility can now keep track of that for us. They can credit us for that extra electricity we don't use. And really what that means is the utility becomes our battery. And it just makes a great function for us to use this intermittent source in the sky, the sun, to now power ourselves indefinitely. So really neat stuff. These are a lot of the pieces that as we start to dig into those who are interested in solar, it's just getting a good grasp on how the net metering process works here in our state, because it does vary state to state. So it's a really important part to kind of review and consider as you start thinking about solar for your home. So once we have solar for the home, we start looking at a little closer at the tools for the job. And that's really what I want to kind of focus in on here for this group, is talking about the tools that we're going to use here, and then how are they integrated? Because again, in my time working with the homeowners who have the love for these older buildings and preserving them, a lot of what we want to focus in on is the aesthetics of what we're doing here, paying attention to how we may be changing the appearance of a building, or why, or how we're integrating into particular areas of the home. So tools for the job, I've got two examples of very current solar panel options that I have available to clients right now. The difference here, what we would see is we have an all black solar panel versus what we would call a white black solar panel. And that's just industry talk for us. The difference being the back sheet. So solar panels are made up of silicon solar cells. And what happens is there is essentially a plastic backsheet that is behind them. That plastic backsheet in some cases is white, and that gives you that contrasted look between the cell and the backsheet. Or you can literally put a plastic backsheet in that is black. And what that does is it eliminates the highlights you would see, or that contrast between the two. But as much as that ups the aesthetics, it does slightly reduce the efficiency of a panel. And the reason being, an all black panel will retain a little bit more heat. It takes in a little bit more sun, and heat can actually draw down the efficiency of a panel. So just unique items to think about. Again, we have a lot of customers that are very, very concerned about aesthetics. And that's where a panel that's all black really kind of meets that need, does the trick. And then we have some that just say, hey, I'm not so worried. I actually like the fact that the solar kind of stands out on my roof. I'm pretty proud of it. So, for me, I'd go for the extra wattage in that panel. And that's really cool. And it's always fun to offer options. So a customer can feel like they have a choice in the process, and we're not just using kind of a one size fits all approach, right? And then from there, like I was saying in the previous slide, taking this solar power and making it usable for us, this is the workhorse. These are the items that are going to be doing the heavy lifting. It's the inverter. It's what's going to convert that energy into usable AC, or alternating current, that we use in our homes now. And the evolution of such is that, these inverters now are 97 to 99% efficient. Now, what does that mean in terms of converting DC energy into AC electricity? So all that energy that runs through these inverters, there's very little loss in that conversion. And that's awesome, because the more we can harness from these panels, the better the impact. So just really neat stuff. Those are the basic tools. And as we go through, we'll touch on some more. But because I'm always talking this conversation, and in my world, we're kind of almost beyond solar. And by beyond solar, what I mean is solar plus. Solar plus what? Why are we doing other things? And we're really at this position where we're looking at the 100% solar home. Well, and why do we do that? Well, solar in most cases now, if we have a sunny location, has become the no-brainer. If we've got a sunny roof, if we've got a sunny spot in the yard, the economics on these projects pencil out in a way where, we can look at, it's almost like pre-purchasing the next 8 to 10 years of electricity, but getting 25, 30, 40 years of electricity. So there's this really great benefit of a little bit of an investment now that really pays off in the long term. And so we can start to look at things and say, well, if we're going to have free electricity at some point produced here on this home, what else can we do with it? And I'm sure many of you are familiar with, the growth of electric vehicles. More and more of my customers are telling me, hey, Eric, I'm going to have an electric vehicle in a year or two. What can I do? And we start to guide them on, well, how much do you drive? And start to figuring out how much that might add to the electric bill down the line, right? So I can start to pre-plan a system for somebody, knowing that they might have an electric vehicle in a few years, give them an adequate amount of solar panels, that now we've not only knocked out an electric bill, but we've knocked out gasoline as well. And it's very impactful. And it's exciting to see that we're at this position in time where we're using technology for the greater good. So as well as the electric vehicle, heat pump technology is very exciting. For those of you who are familiar with it or already have a heat pump in the home, this is a great way to provide heating and cooling. And when we get down to the options in the marketplace, it is hands down the most cost-effective way to heat and cool a home. And the fact that it's electric based means, again, take solar, we put an adequate amount of solar, and now we can get our heating and cooling from solar on the roof. Water heating falls under this as well. You've got options, whether it be, again, utilizing a heat pump technology from a water heater or just using a traditional electric water heater. It all comes down to how much space we have, what are we looking to do, how many panels can we put out there, what can we produce, and then we can just build this design that really takes us away from fossil fuels and sets us up not only financially, but really in a way where we've reduced our carbon output. And when we go back to thinking of things like, hey, 7.5 billion people now, 10 billion going to be here soon. These are the steps we have to take to continually reduce the impact each one of us has as time goes on. And then really, before I change slides here, one of the things that I'm talking about a lot these days is battery storage. It's an exciting piece for most. And it's something that we can all look at as something that we could go for instead of the traditional generator. And when you have something that's cleaner, it's quiet, it doesn't require maintenance. Those are some nice pieces that really can excite the next client who might have said to themselves, hey, I need that generator. We've had a few extra power outages over the last few years. What can I do? Well, battery storage can sometimes be that solution that is, again, quieter, cleaner, and fits the bill here for taking solar and taking it to the next level. So just to go through, show you some of this stuff. I know we're wanting to talk solar here, so I don't want to spend too much time on the ancillary items, but just giving everybody a good sense of what does that look like? What are those parts and pieces? So for those who don't have a heat pump, this is kind of your traditional indoor unit here. You kind of set these up locationally within the home. And there's a corresponding outdoor unit to these. The outdoor unit is what does that work in terms of extracting the heat from the air outside. Again, the magic of a heat pump, for those who don't know, is the fact that it does not create heat. It simply moves it. It moves it from the outside to the inside. And it does so through a refrigeration process and condensing that heat down so that, on the outlet in here, you could have 100 to 114, 115 degree air blowing inside when it's only 30, 20, negative 15 degrees outside. These units can still extract heat and bring that into the home. So those are really neat as well. Again, continuing on that theme, the heat pump water heater, great tool. These are one of the tools that, for the homeowner who comes to me saying, Eric, I want to cut down fossil fuel demand. Well, in most cases, like this guy here, this is an oil boiler that had historically an indirect tank. Oil would have been making the hot water here. In most homes, you look at making a switch like this, the average home is going to save anywhere from 300 to 350 gallons of oil annually for that hot water production, just by making the switch to a heat pump water heater. Now, the heat pump water heater is neat in fact that, again, it's an Energy Star system, uses a small amount of electricity. And in most cases, what does that mean? You include an extra 3 or 4 solar panels in your project, and now you've covered your future water heating. So it's a really cool tool that, again, adding that to solar just takes us to the next level. And again, like I said, exciting times with solar in terms of electric vehicles. I'm talking about this more and more and more, and it's exciting for myself, a car guy growing up, and to now see more and more models becoming available in the marketplace. There's just more choice. There's more that we're doing. The ranges are increasing. The quality is increasing. So, another thing that we're always offering is the ability to charge those and that infrastructure that's available lots that you can do. You can add in a dedicated charger, or nowadays we even have the advantage of utilizing the solar inverter directly as the electric vehicle charger. So if you're somebody who wants to have, that awesome feeling of knowing that you're literally driving on sunshine, you can go from your solar panels to your inverter without even inverting. So there's a bypass here that just takes that solar energy directly from the roof and shuttles it right into that car. So that car is charged directly from those solar panels, and it's just awesome. And I have a lot of customers that is a piece that just excites them to no end, because they can now say, I am driving on sunshine, and it's cool. It's really exciting times. So that's the electric vehicle piece. And then looking here, lastly, solar and batteries. This is, again, one of the growing pieces of the industry. Things are really kind of moving fast here. And to touch on that, I talk with a lot of customers all the time, and they say, Eric, solar's great and all. I'm excited about it, but what's coming? What's coming down the line? Is everything going to be different next year? Is everything going to be different in a few years? If I buy something now, am I shooting myself in the foot per se? Right. And I say, no, we're at a great position with solar. Solar's now starting to hit the upper end of the limits of what can be done within the silicon solar cell. The panels on the marketplace right now are achieving 20 to 22% efficiency. If we go back 30 years, the average efficiency of a solar panel was 7 to 10%. That means we've really only doubled in the last 30 years. And when we compare that to other technology like our computers, our smartphones, and we watch those just accelerate over time, you really realize, wow, it's actually taken a lot for solar to eke out this little bit each year over year. So the jumps in solar don't happen at the same degree as a lot of our other technology. So from the aspect of looking at it as an investment and saying, well, is it still going to be relevant in a few more years? Yes. However, when I look at the battery side of the market, this is the new stuff. This is what's moving. And not to deter anybody, but this is the stuff that I consider still more the early adopter phase, because it's unique. It's integration of a product into the home that we haven't historically had. And batteries are really, the success of the battery, or what the battery can do, is really, really determined by each homeowner, because the variables change with how a homeowner might use their home. So, the conversation when I have a customer who's asking about batteries, it really comes down to, well, what are we doing here? Let me look in your circuit breaker panel. Let me see what you have. Do you have a hot tub here? Well, we're probably not going to want to have the hot tub on the battery. And I don't think in a power outage, you're going to be worried about that hot tub. And the customer will say, okay, yeah, you're right. And for me, that just lets me know that now I've taken out a heavy load. I've taken out something that might draw that battery down too fast. And I'm building that client a better design. So that's really the tools that are out there, the things that I would kind of put into everybody's mind as the options that just pair so well with solar, and kind of bring, again, as we talk here about the old home, old barn, bringing that new technology, blending that in, and again, carrying on what we're preserving here with these old barns, old homes, and just bringing them up to current times, and watching them succeed, and just really do a great job of, again, minimizing any of that carbon footprint that we have from just our daily life. So because I haven't shown you too much yet, I wanted to throw up a few pictures here of just some examples, some stuff I have here. I wish personally I had a little bit more knowledge about some of the projects I had here. Just going through looking for some pictures. This gentleman here, this is a gentleman in New Boston. This home here was built in 1860. Phenomenal project here. He's right on the main road in New Boston, and he is just ecstatic about his system. And you can see here, it blended very well with the home. I mean, you have to look up at the roof, you have to see it, but in my eyes, and I think to many others, you see that kind of that duality of, the old home, the new technology, and it just really has this neat look to it, and a really a desirable piece. a customer of mine up in Canterbury. This is a barn over in Maine. And you can see there's various layouts, there's various roofs out there. So there's a lot of customization to this, and making sure that you run through these options for each homeowner, make sure you understand their goals and needs, and design this appropriately for what is available. For any of those who might know, this is Winnie Chocolates up near Winnipesaukee, home run business, but they have an older home there as well. And while I'm looking at it, just touching on the different roof types as well: asphalt shingle, corrugated metal roof, standing seam metal roof, right? A lot of these items, they're all things that we have currently existing on our homes, and each one has a different pro or con, if you would, in terms of what is integration of solar look like on that. This just happened to be a really great shot here that we had done a drone shot. But for myself, anytime I have the opportunity to look at an old barn, particularly, I'm excited by that. One, I have a love for an old barn, and I wish I had one myself. I don't currently, and I hope to eventually in the future, but I'm always very jealous of the homeowner that does. And part of the reason why I am is because if you just look at the surface area that an old barn provides for you, there's a lot of room there for solar. There's a lot of room to go through and start to now say, well, my electric bill is only X amount of dollars, and that I only needed 20 or so solar panels to cover. But I've got a drafty room over here. I use about 800 gallons of oil a year for heating. And geez, why don't I switch over to a heat pump solution, throw some more solar panels on this roof? And you know what? The old car, it's 12 years old now. I might as well get a new one, and I might as well start thinking electric vehicle. So it just opens up the possibilities, especially the larger roofs, the larger barns. Um, but while I'm on the barn piece, it is always worth mentioning that, and this group likely knows that, as we go through and we restore these and we take the time to make sure we're maintaining that original design, the original build, the original architecture. It's one of the pieces that, just part of code for going solar, is we do have to do an engineering assessment of that roof surface. Now, we don't have to do an engineering assessment of the entire building, but we do want to know that that load on the roof does not cause any flex of the roof, and it does meet current snow load requirements per the town. So that's just one of the things that it's a little hurdle for some, and it's just something that I always mention, because it is something that could arise where, when you look at what we might need to do in some cases, if a building doesn't pass that engineering review, you do every so often need to rectify that. And then there's work that can be done. And again, in my time doing this, I've been very cognizant of each client's desires. And I've had many who have, gone through the painstaking efforts of making sure that their buildings are recognized by the historical society, and they do not want to change anything to those barns. So we have to look at the options. And in those cases, those homeowners will opt for a ground mounted solar system. But as you can see here, and through the pictures I have, there are more than enough opportunities throughout this state to look at the barns and the old homes that we have, and start to assess them for their solar opportunity. So, on the theme of, again, integrating this into the home, I thought it would be good to go through some of the installation steps. What does that look like? And start to describe that for this group, so that you can start to get a better idea. Okay, well, I have that barn out there, or I have my old home. What do I want to do? What is this going to look like? What's the process going to be? Well, we've got to get out, and I tell people straight up all the time, if we have an asphalt shingle roof, we have to come and drill holes in that roof. And for me, I'll tell you, in my time in carpentry, I had a short period where roofing was what I had done. And everything I learned at that point in time was, we never put a hole in the roof. Why would we? We're trying to do everything we can to make it penetration free. We're trying to make it watertight. We're trying to protect that investment, right? I spent 3-4 months out installing solar with the crews when I made a transition here to Revision, and I learned a lot about our process. And then over time, that process has gotten better. But what you see here is what we call our racking structure, or the rail system. These rails will run the length of the installation location. And each of these shiny little spots you see here, this is not totally typical of a standard design, but I chose these pictures to show you this because they stood out a little bit better. And what I'm getting at here is these silver squares here are typically anodized black. And that's just simply so that they blend in a little bit better with the building. If you keep all your hardware black, things tend to look a little cleaner at the end of the day. But what you can see here is each of these points here denotes a penetration that was made. So this is a flashing kit that is installed with each of those penetration points. And there's a process there of injecting some sealant, going through with a few different rubberized attachment points. So not only are we using the sealant, but we have some mechanical capabilities of sealing that as well. And there's a painstaking kind of thorough process, training process that our teams go through to make sure that really this is a piece of attention that we're really focusing on, because this can make or break a project. The last thing you want to have is have a beautiful system up there, everything's tied in, it's all done, and then months later it rains and the client goes out and finds a leak in the home. Luckily for us, knock on wood, it's a very rare occurrence because we put so much attention on it, but it does happen from time to time. You got to go back and rectify these things, and that's easy enough to do. But again, it's kind of cutting all of this off at the pass and making sure you just hit all the check boxes on the first go around is truly important. So looking at this here, one of the other items we can pull from this is just to kind of highlight the various pieces of equipment. This right here is what we call an optimizer. This piece here goes with some of the inverters I've shown you in the previous slides. But what this neat little item does is it goes with each panel individually. And now what it does is it tracks that panel individually. And from a monitoring platform, for those that are kind of more on the tech side and like to see some data, like to watch this stuff, can now see how each panel actually operates individually on that roof. So what you have is the individual data per panel, you have the total data for all of the panels together, and you have that day over day, every day of the year. And then you can start to compare year over year how the system produces. And one, it's great for the homeowner, but two, as the provider and maintainer of these systems, it is a great way for us to keep tabs on this. Now, Revision as a company has over 10,000 systems in operation. We can't actively watch all them, so we rely on our customers to access their monitoring portal, go through, make sure they're looking at some of these items, and kind of give us a note, send us a note. And that's really simple on our end. We've set up a whole system where you just email service at Revision Energy and we follow up and we can start to do some of this stuff. But because we're in a position these days where everything's connected to the internet, well, so is your solar electric system. And it's very easy for us to do some troubleshooting from afar without even having to roll a truck out, so it's a great piece, a money saving item for us as the maintainers, but it's also a great way for the homeowner to continually ensure that their investment is producing that energy that was promised. So that's how we get solar panels up on the roof. And there's various ways. Again, each roof might have a multiple pitches, different ways to do it. Sometimes instead of running horizontal with the roof, the rails will have to run vertical. And that is what you see most often with a corrugated metal roof. So for those who don't know the difference there, the standing seam and the corrugated, the standing seam metal roof is the nice clean metal roof that has the big flat spots in between. We have a seam in the middle. Corrugated, when we look up at it, tends to be the wavier of the two. And what happens is you actually have mechanical hardware that you can see holding each of those panels down. Different ways to attach to each. But what we find most often is that you'll tend to have to use your rail vertically on a corrugated metal roof just due to the way that it lays out and typically the structure underneath. So again, it's one of those pieces that as we talk through expectations with the homeowner, what will this look like? It's starting to identify a lot of that stuff early in the process and just make sure that people are aware, right? From the roof, the next piece that is always important to talk about is how do we get that power down and into the home, right? And most commonly it's done through a metal conduit, so EMT, typically a 3/4 inch to maybe a 1 inch in some case EMT, and that's got to run down from the roof. And how do you do that? Well, in the middle here I'm showing you a simple opportunity where we would run out have a junction, come out and around the rake, get down the side of the home. But there's other opportunities where, hey, maybe we had the access in the attic and we were able to penetrate into the attic, get the electric runs in, and then we could come out the gable end. And if we could come out the gable end, then maybe we could run everything nicely down the rake, down the corner board, and just keep everything in a way that it was slick, kind of out of sight. And even then, being that it's EMT, you can actually go over and paint these later, paint them to color match, and then even then they disappear into the wall even more. So these are the items that I'm always trying to kind of highlight for customers, because we want to know what this is going to look like. We're going to know the impact on the buildings. And I think even more so for those who are making sure that they're preserving these older homes into the future. And once we've got all that power coming on down, it's all about plugging it in. And so I kept mentioning the inverters that we were talking about. This is just an example here. This is a 2 inverter system. So you're likely probably looking at a 45 to 50 plus panel system. And that's why we had 2 inverters here. But what we need to do is locate the main service panel in the home. And from there, learn if there's any upstream disconnects before we get to the meter. So, every once in a while you have a home where sometimes there was an extra disconnect that was installed, maybe in the garage or maybe out on a pedestal. So we have to be aware of those things. So we kind of know how this configuration works. Where are we going to plug our stuff in? Where are we going to be able to install these inverters? It's unique when you start talking a barn. There's usually a lot of flexibility and a lot of space in a barn. Very easy to hide these. In an older home, especially, something with a dug basement, something that's still got a fieldstone wall. A lot of times we're building, say, a temporary wall, or we're putting up a wall that's just going from stud to floor. And it's something that's kind of there near the main panel, gives us a location to install this equipment. But again, kind of looking at all those factors and figuring out where can we put things, what's going to work here. And that all at the end of the day will distinguish, what a project may cost for each customer. So as you can imagine, those of you who have put in the time and effort to go through having some, renovations done, some construction work done, a lot of times you can get in and costs can change over time. As you dig in, I know in my past, anytime we would go, replace a window in an older home, it really turned into replacing siding, replacing some framing. You just go in and chase the rot sometimes, or chase where the bugs have kind of gone. The benefit here with solar is that a lot of times all of that can be sussed out way ahead of time. So the cost changes, again, other than anything that might be particular to the roof structure. And
Eric,
that's,
excuse me, Eric, we're down to like 8 minutes or so. Okay.
thanks for the heads up. Nope, my pleasure. Almost done here.
Okay.
So that right there, again, just looking at some of those items, and how it will all fit in, how it will plug in particular to your home, how that works. And in some cases, again, as we talk older home, as many of you may know, your wiring may be of an older vintage. And that's a part of the conversation as well. And also a great opportunity to upgrade stuff that might have just been overlooked over the years, because the advantage of having a tax credit with solar right now, if we do include work that is additional electric work to make solar happen, it kind of goes all under that same receipt, meaning that you can take your tax credit on that additional electric work as well. So that, all in all, is kind of the quick over on solar. As you guys can tell, I can keep talking on this stuff. But I think at this point here, you can tell me, Beverly, I don't know if we have any questions that have been popping up in the chat, anything else that you could think of that you might want to bring up as a topic that I could chat on, but happy to continue on.
Yeah, no, we have lots of questions. Great
Wonderful.
questions too. One of which was, this is a wonderful program. I hope my husband can watch it later. So yes, we are recording, and it will be on our website tomorrow. And it will be included in a post-session e-communication I send out tomorrow. All right. This is a really good question. The difference between placing the panels on the building itself or mounted on or put on the ground adjacent to the building. Is there an efficiency difference, cost perspective? What's the difference?
That is a good question. always looking at these from opportunity to opportunity, right? The benefit of the older home and barn is that almost all the time, these are oriented in a way where we have a roof that is due south. So we have a great opportunity there to utilize the home. Now, if we happen to have something that is more of an east-west orientation, and we look at a spot on the ground and we say, hey, wow, we've got a great little flat spot over here. Looks like we've got great sun exposure. We can make the case that because we can orient the panels in a perfect angle, perfect orientation, we can get more energy per panel on the ground than we could on the roof. Now, the difference becomes when we have a roof to work with, that's great. We are just mating panels to that roof. However, when we're going to build something on the ground, there's a larger scope of work there because we have to build the thing that we are going to put the panels on the ground. And at the same time, we need some heavy equipment to come in, put in the foundation for that system. And then we need usually an excavator to come in and dig that electric run trench from wherever the point of location that we're going to bring solar into the home to the location that we're putting solar at. So depending on the scenario, you could see that solar on the ground may cost anywhere as 15 to 30% more than what it might on the roof. But as time goes on and as costs stabilize a little bit, I've seen many times now, more recent, that it was actually more cost effective for the customer to use the ground location than the roof location, especially when we look at something where the roof may be aging and needs to be replaced. And, we might be 20 years into that roof life and it probably got 10 years left, but if we wanted to put solar on it, it would be best to replace that roof. And sometimes looking at that cost will help us shift back to the ground instead of the roof. So I hope that helps.
Yes, definitely did. Another one relating, you had mentioned structural engineers needed if you want to install in a barn. Someone asked, does Revision Energy engage that structural engineer, or is that the property owner's responsibility?
Good call. On Revision Energy's end, everything we try to do for the homeowner is turnkey. We do use a third party for our engineering. We do have structural engineers in-house, but we do not use them just for that conflict of interest. We don't want to have any of our engineers just looking at a project and really wanting to go through and make that happen. So that is all coordinated through us. And we will guide you through the process where typically if a roof does fail per se, we get an engineering assessment. We get to pass that on to the customer. The customer will get a quote from us to do the work, but we also always encourage our customers to say, hey, if you can complete the work yourself, go ahead. If you want to have another contractor come in and do that work, please do. Because for us, it's probably going to be a handful of our electrical apprentices that have some carpentry experience doing the work. But when we start to compare what those electrical apprentices cost per hour to do some of that work, a lot of times it will make more sense for the homeowner to complete the work or have another contractor do it. But we are always there to help with that and do that work.
Excellent. All right. And then there are a lot of questions relating to roof materials. Somebody asked about slate roof. Others are saying if you do need to replace your roof prior to an installation, what do you recommend for the best type of roof under panels?
Cool. I'll start with slate because slate's really one of the few kind of no-goes on my end. I've had some time personally myself replacing slate roof. I had done a project in Epping when I worked for a carpentry outfit where the home was hit by a tree and we had to do a big replacement of slate. And if anybody who has slate knows, the wind can blow and kind of knock some of that old fragile slate off the roof. So we never want to kind of integrate with a slate roof. Just in that case, it doesn't work out. It's not worth the time there. Now, talking about what's the best roof surface, it depends. Majority of the time we're going to work on asphalt shingles, and if you look out and see what is out there nationally for roof types, it's asphalt shingles. So the industry has been pretty well focused on making all sorts of attachment points, all sorts of flashing kits, all sorts of good tools that work well with asphalt shingles. Now, with that said, if we wanted to ensure that, we have a penetration free installation, then the argument can be made that standing seam metal roof is superior just because, we can use the seams of that standing seam metal roof with particular attachment points, for this industry, that we can use to hold all that racking rail that I was showing you earlier, right across the roof there, mount all the panels to that, bring your electric around the edge of the roof, around the rake and down the side of the building. Then there never has to be a hole in the roof. So it's not that I would say it's better, just because, one, I know the cost comparison of a standing seam metal roof to an asphalt shingle. And I'm very confident in the way that we install on an asphalt shingle roof that it will be weather tight. So it's just a balance. I mean, if somebody said, I want a bulletproof system, I'm fine with investing into my roof. Of course, I'll encourage the standing seam metal roof. If you talk to all of our installers, they love it as well. It's a little quicker on their end. The tools needed on the roof are a little different. We don't need to drill at every spot. We don't need to measure out as much. We just need to get that racking up. We need to make sure it's supported. And then in between the two is corrugated metal. It's a blend. You've got the benefit of having a metal roof, so less wear on the roofing product itself over time, but we still need to drill some holes. And so there's kind of that in between. And again, corrugated lives kind of in between the cost of asphalt shingle and standing seam metal roof as well. So it depends on the homeowner who's going to think what's best in the end, but there's a lot of options there for sure. So hope that helps.
So there may be some cost savings on installation with standing seam. Is that true?
Yes, but it won't be enough, unfortunately, to justify that delta between asphalt shingle and your standing seam metal roof.
Yeah. Okay. All right. Here's a very technical question, way above my pay scale. With electronics, LEDs, et cetera, being DC, is there any way to use the energy before the inverter to power those? The inverter may be 99% efficient, but all the wall warts, powered bricks are not. Realize this may be long-term change to residential electric infrastructure.
Well, the last part of it there highlights it, right? It's just, it's a different change. So can it be done? Not off the current equipment. The current equipment that we are going to use right now are grid tied inverters. The grid tied inverters need to sense that grid power, and it's part and parcel that they need to do the inversion before it enters the main service panel of the house. So there's no way for us to access that energy. Now, could you build a DC system? Yes, DC systems exist. Those are traditionally off-grid only systems. So what you would have is you would buy your DC fridge, your DC lighting. You can buy all of that stuff for a system. But again, those are really kind of relegated to the off-grid system. Still, it does exist. It's something that can be done, but for the most part, the homeowner will not be able to grab the entire benefit of that system now, like we promote with the systems that we're installing now. You just don't get that same return on investment. You're not connected with the grid. And again, it's usually on the smaller scale that you do a system like that. So not currently integratable into the systems as we design them, but DC systems alone do exist, and you can build those if you wished.
Okay, thank you. Wintertime, does snow need to be removed from the panels?
Very common question. So this is a good one. Looking again, if we're just kind of whittling it down to the old home, old barn, most of us know that those old homes and old barns have a fairly decent pitch to the roof. Most often we're kind of somewhere between that 9 to 12 pitch. So anywhere from about 35 to 45 degrees. Really, when you put solar on that roof, it is glass surface. A glass surface works just like a metal surface. So any of you who already have a metal roof on the home, you've experienced that avalanche that can happen in the winter. A few inches of snow builds up and it comes flying off that roof. Now, with that said, not every roof is at that great of a pitch. Some are lower, some will hold their snow. However, due to the height of a roof, due to the time of year as well, and the fact that in the winter is your lowest producing time of year, we never advocate for anybody to go clean their roof off. In most cases, if we did the math on it, your sweat equity into removing that snow not only that, but putting yourself in harm's way. If we just look at the picture I have up right now, you could imagine trying to get the snow off of this roof. Any of that lets go, you're going for a ride. So we say, don't remove the snow. It's also best to kind of leave the system out there. If we're kind of out there whacking away on it, trying to remove the snow, we may cause damage that we never intended. And it's just another problem. So no snow removal. Could it be done? Sure, there's some techniques, there's some ways to do it. My customers who have ground mounted installations, those stand at a height that it's very, very easy to access them. And they tend to clean them from here to there, but it's not something that we recommend nor promote because again, you can put yourselves in harm's way or just potentially accidentally cause damage.
Okay, great. Here's another roof related. Let's see, he has part of his roof is shaded. And how to handle that? Just put more collectors on or cut the trees?
Yeah, each site has its own unique kind of variables that we want to take into consideration. And if part of that roof is heavily shaded, we can do a couple of things. Could we add more panels in that location? Sure. But we might find that that's cost prohibitive for the project. So then we look towards the tree removal side. Well, can we remove those trees? Are we in an area where that's doable? And so those are the things that will start to balance out. Is there an area where we can move to another roof? So if we have a roof that really half of it gets a really good amount of sun, but there just happens to be this tree, it's an ornamental tree. We don't want to remove it. We love it, but it gets shade over half the roof, pretty consistent point of the year. Well, do we have an adjacent roof we could use? Could we move something to the ground? But without even thinking that, there are plenty of advantages now within the inverter systems we have. The one I've been showing here, there's another version. I didn't show it, but it's a great option as well. They're called micro inverters. So what I've been showing here is where you have a larger inverter that's down inside the home. There's another option called a micro inverter that lives up on the roof under each panel. And in the heaviest of shaded locations, that now allows each panel to operate individually and can get you more harvest. And again, capitalize on the moments when those shaded panels possibly do get sun, when the leaves fall off at some point in the year. So there are some tricks that we can look at to say, hey, how can we maximize a certain location? But shade is always something I'm trying to identify. And when I'm at site, I don't have it here by me. I wish I did. My little sun reading device. It's called a Sun Eye. I get out and it tells me the amount of exposure we have on a site. And I can really start to dial in how impactful some shade might be on one side of the roof. But multiple approaches, multiple ways to look at it. And usually we can get around a shady location.
Okay, great. Another technical question relating to heat pumps. What are your thoughts on geothermal and how it works with solar?
Geothermal is cool. If you can do it, go for it. In my time, and this is just my opinion, I've seen a lot of customers use geothermal. And what happens is the expectations set on geothermal didn't meet what the was intended for that customer. And again, there's nothing wrong with geothermal. There's a phenomenal technology. The fact that we are now taking, again, very similar to a heat pump, we're utilizing the temperature down in the earth or out, there's multiple ways we can use it in terms of the loops, whether they're long and low, deep down, but we're going to grab the heat from the earth and we're going to amplify that just as we would with the heat pump system and use that to heat and cool the home. So it's great technology. What I'm getting at is it tends to be energy intensive. And unless you're working with a proper builder who has done that, knows what they're doing, knows how to run the calculations, and you're starting from scratch, those that go and do a retrofit style system, I find more often than not, the rise in the electric bill is very close to what they were seeing for a fossil fuel demand, fossil fuel usage. So that's just my kind of what I've seen out there here in our region. It's not to say there aren't successful systems. I have a customer over in Londonderry that recently did a geothermal system and solar. We worked together to kind of understand what historic heating demands were. I worked out all the calculations to know that the current electric increase was going to be a certain amount, and I just compensated for that in the size of panels. In that example I'm using there, we used roof, we used ground, but we got there. And that homeowner is now essentially net zero because they've got an electrified heating source. and they're getting all of that clean electricity from solar. So Geo is a great way to go. I don't love it as a retrofit personally, because there is a high bar of entry, and heat pumps kind of give us a lower bar of entry, and it's an easier retrofit item. But yes, Geo is a great option for those who have the space, have the means. If you can do it, go for it. Just do your homework on it and make sure you get it right.
Okay, thank you. Here's one, a Massachusetts resident. My Massachusetts town is a town-owned utility company. They say they only pay wholesale price for solar panel generated electricity. How does that affect return on installation?
Dramatically. So what'll happen right now, I'm not familiar with Massachusetts as much anymore. I used to go into Mass before our Massachusetts branch in North Andover was established. And since then, there's been a lot of changes in their market and the structure for their rebate system. So I'm a little bit removed from it, but I do remember talking with those that were in a municipal electric service location. And what happens, right, is, on average in Massachusetts, your electric rate may be, anywhere from 18, 19, 20, 25 cents per kilowatt hour. And if we use that while it's being made from the sun, wonderful. But if we're making a surplus amount and we're using that exchange, that net metering with the utility, and they're only going to give us 3, 4, or 5 cents for every kilowatt hour we gave them, well, that compensation that we get just kind of leaves us behind. And we're always trying to make up that difference. So what happens is, the solar project that would have returned its investment or become free electricity, paid itself back by, say, 8 years, now pays itself back by 12, 13, 15 years. And it just extends it out because we're getting less value for every kilowatt hour that we produce. But you're in a position now, especially in Massachusetts, it wouldn't hurt to kind of start doing a little bit more work on this on your end, to do some homework, because again, I'm just not as up to speed on it. Looking at what the battery incentives now are in the Massachusetts market, because I know they're better than they are here in New Hampshire, and start to look at what you could do in regards to utilizing a battery with your solar. And by doing so, you can eliminate the amount that you're going to export out to the utility and essentially stop sharing with the utility. Keep it all at home in your battery. And while it might be a more costly upfront investment than just doing solar alone, it could actually probably return itself faster than if we just put that solar on and just relied on the utility to pay us back for our excess solar.
Okay, we're getting down to 1 o'clock. I'm going to do one more question, and then I'm going to do my wrap-up comments for those who have to leave at 1. And then we'll continue the discussion because we do have more questions. Let's see. How much does a panel weigh? That's one question.
Cool. Yeah, the panels themselves, really about 25, 30 pounds. When you look at displacing that weight on the roof, though, once they are installed, it is about 2.5 to 3 pounds per square foot. So really, when we consider the weight of shingles on the roof, it really matches roughly the weight of shingles once they're distributed amongst the roof. So not significant, but again, going back to all that engineering review I was talking about, sometimes that can be the straw that breaks the camel's back in terms of the calculations and just going that shade over. So really not that heavy at all, and easy enough. I'd say easy enough, but for those who can handle, putting it kind of on your shoulder, climbing the ladder, it's normal to see a single person carry that solar panel up to the roof.
Okay, and relating to that, with barns or even with houses, have you found that there are many cases where you do have to strengthen the framing?
Yeah, and it's a thing over time, right? So one of the distinguishing factors that I know here in New Hampshire is the further we go north of Concord particularly, the town snow load requirements increase. And what that's from is historical data showing the amount of snow that those towns may experience. So building inspectors over time will update their requirements. So what does that mean? What could have been historically a 50 pound per square inch snow load requirement back in, who knows when, could now have been updated in, 1995 to now be a 70-pound snow load based off of historical data. And what happens is the home that was built really only met that 50 or 55-pound limit. And then we come in, and even though we're not going to add much with solar, this home doesn't meet current requirements. So the further north we go, the higher the likelihood. But then other than that, it can really come down to one with the barn or the home, even what was done over the years to that home. In some cases, we all know, a previous homeowner may have changed a bunch of stuff. A previous homeowner may have changed the roof in some way for better or for worse. So a lot of times it's really site specific. I've struggled with this over time to just help each customer kind of understand how likely it may be for their home. And even myself, with the thousands of homes that I've been in, the thousands of rafters I've reviewed, the attics I've been in and looked at, I can still only go by a few items to say, well, if our rafter spacing is such, if the size of these rafters is such, maybe, and maybe not. So we have a lot of factors that come in there. And again, that's why we kind of lean on an engineer to do that work. But I would say, if you had to ask me, like, how often does that happen? I would say overall, maybe about 10% of projects in general. But if we had to look at older homes and kind of separate that out and say older homes and barns, maybe as much as 40% need to have some sort of additional work to make them a usable roof, or something that would pass the snuff of the engineer and the building inspector.
Okay, great. Thank you, Eric.
Mhm.
All right, so at this time, I think I'm going to wrap up the 1-hour program. And again, feel free to stay on for an additional 15 minutes or so, because I know there are questions we have not addressed. But at this point, I want to thank Eric for this really inspiring and informative presentation. It was wonderful, and it certainly has pushed me over the edge to want to do a little more research on putting some solar panels on our barn. We happen to have a new barn, but definitely worth looking into. We love getting like-minded folks together to share this type of information, make connections, and offer a dose of energy and inspiration too. Thoughtful and experienced presenters like Eric, and your great questions. I really appreciate all the wonderful questions everyone has submitted today. Really make a big impact on advancing preservation efforts across New Hampshire. We want to know that the Alliance is here. If you have additional questions relating to this subject or any other with preservation, old houses, barns, feel free to check out our website, nhpreservation.org, or send me an email, bt@nhpreservation.org at any time. If you haven't already done so, please check out our website for the full schedule of Expo on the Road programs. Next week, our Expo sessions include energy efficiency in older homes and porch history and preservation. So more information, again, is on our website, and you can register on the website as well. We hope today's program has inspired you and advanced your consideration of a solar project. We look forward to seeing you at future programs, and encourage you to share our Expo website link with other old house and barn enthusiasts. And be sure to check out our Expo guide of 50 products and service providers on the Expo page of the website. Okay, and for those of you who have been to our in-person Expo in the past, you know how we love to give away door prizes as our appreciation of your participation. So at this time, I'd like to turn it over to my colleague, Nicole Flynn, who will announce the lucky winner of today's book, Preserving Old Barns, Preventing the Loss of a Valuable Resource by John Porter. It's a great practical handbook, a must read if you own a barn or are a barn advocate. And if you're neither of those, it's a great gift to a barn lover. So I'll turn it over to Nicole.
Thank you, Beverly. I randomly chose a number using a random number generator online and got number 11, which came up with Janet. Janet, you're our winner of our book.
So Janet, are you here? I see Janet. Do you want to unmute yourself? Maybe she's, oh, well, that's okay. Janet is our winner. And Janet, we will make sure we mail that book to you. We will be in contact. So again, thanks all for participating. Please watch in your inbox. I'll be sending a follow-up email from the Preservation Alliance with links to other preservation resources related to solar and our upcoming Expo events, and also a short survey that will help us plan for future programming. And please help keep the Preservation Alliance vibrant by making a donation or consider a gift of membership. Thanks again to Eric for his great presentation, especially during this very busy time of the year. I know he's out flat with meeting customers. To our Old House and Barn Expo sponsors, which are listed on the screen right now, including Revision Energy. Thank you, Revision. And to all of you for joining today, we wish you all well and look forward to seeing you at future programs. Thank you for joining. And again, if you want to stay on for additional discussion, feel free to do so. Okay, Eric, there's some more. We've had great questions today. Somebody mentioning that his barn is southeast facing. Can you talk about the best orientation, and at what point is it not good enough to even consider putting panels on your roof?
Really good question. This one is one that comes up a lot because, again, we commonly hear that unless it's south facing, unless it's directly south, we're not going to be adequate for for solar. False. Really, for me, over the time that I've done this, it's getting to that roof surface, seeing how much sun we get. So especially something that's just a shade southeast, just a shade southwest, no worries. I want to know how much sun we get there, because we're only talking a small percentage decrease in terms of annual production when we're only off by a few degrees, right? So it's not a huge deal. And really, I have plenty of customers, and there are plenty of installations that we've completed that are on almost completely west facing or east facing roofs that, aren't facing south. And as time goes on, as the cost of solar continues to decrease and we have these great incentives, we can find locations that 5, 6, 10 years ago we would have considered suboptimal, that everything works and pencils out now. So the opportunity there is such that if you think you have an area that is receiving 6 to 8 hours of sun a day, call us. We'll look at it. I mean, that is, if there's nothing blocking that roof, it doesn't really matter to me the location, as long as it's not turned north. That's the only one I don't want to see. I don't want to see the north facing roof. But other than that, really, east, south, and west, it's got an opportunity. If it's getting a lot of sun, let's look at it.
Great. And another question relating to that, someone who owns a property in a historic district where there are restrictions, I do not believe they allow them on the front facing parts of a roof. Have you had experience with installing, say, ground mount or some other location in a historic district?
Very touchy topic.
know.
This one is one that yes, I have some direct experience. Myself, Hollis in particular is a town that I'm always kind of in and around, talking historic district, but also talking kind of ground mounted issues, because the town of Hollis in particular is one of the most restrictive in terms of a ground mounted installation here in the state. Portsmouth, and a few other towns, Durham in particular, around there, historic districts are pretty picky. Here's the thing though. A lot of historic districts will allow solar to be installed on the roof as long as we're using an all black solar panel. All right. So there has to be a review process in most cases. You can go through, but it is usually worth checking with us, seeing which town we're in, and we can guide you on that. When we start talking the situation of we're in historic district, we cannot use our roof. The town's already said so. My first instinct would be that we may not be able to go to a ground mounted installation, just because what's preventing us from putting them on the roof might be very similar to on the ground. So it's always worth asking though, because depending on the town, the rules change. And that's one of the things that can be a little difficult with a technology like solar. Each town gets to kind of make their own rules. So we have to learn those as we go, and we have to kind of know which towns allow what in what locations. And that's just what you pick up over time. But yeah, there's definitely always worth contacting somebody like us, asking that question, and we can guide you on whether or not it does make sense. If I knew more about which town, I would guess maybe we're talking Hollis here, just because of my travels. But yeah, always happy to help. If you want to, my email was up here. Email me, and I will happily answer that question for you if you can send me which town it was.
Okay, thank you, Eric. And a related question from Jeremy on how LCHIP views solar historic roof on a historic building. Jeremy, I actually have no experience with LCHIP and solar, so I really don't know. And I would highly recommend that if anybody's interested, to speak with George Bourne at LCHIP to discuss. And I'm sure they do it on a case by case and need more, really the specifics of the site. Okay, weather, how does weather impact the system? Snow, heat waves, extended cloudiness, hurricanes, etc.
We have to plan every installation to particular parameters. So you have 120-mile-an-hour wind requirements that we need to make sure all the attachment points adhere to. So wind, we're fine. We got a lot of wind loading in each of the panels. Weight loading is typically such that the panels can take roughly about 6 foot of snow on them before it became an issue. Just in terms, it's one of my better references in terms of just giving you perspective on how much snow can sit on top of a solar panel. Most cases, I'm more worried about the roof underneath the solar panels than I am the solar panels when we're starting to talk the weight of snow. Almost every solar panel that's within the industry is designed as such to take a golf ball sized hail. So when we start talking, taking a good shot, taking a hit, stuff falling on it, they're very resilient. I mean, these are a product that you have major manufacturing putting a 25-year warranty on in most cases. So there has to be a lot of resiliency built into these. The glass is super strong, the aluminum framing, all of it is designed as such so that you can withstand the elements. When we start talking, like we had said, snow, we don't want to worry about cleaning them off. Cloudy weather is one of the things that, in terms of how I design a project in general, when we look at the Northeast obviously is not the sunniest spot in the country here. So we are designing in a particular way, and I will design a system here differently than I would design a system that's, say, getting installed in Phoenix, Arizona. We're under different conditions. It's sunnier out there. So what I mean by that is the relationship of the amount of panels, or the wattage, collective wattage of the panels per the collective wattage of the inverter. In most cases here in New England, you're going to want to put a system on the roof that's about 20 to 30% larger than the inverter that you're using. Reason being is low light production. We need the aggregate of those panels under low light production to turn that inverter on to allow that production to happen. So again, those are some of the aspects that we will look at as we design that system to ensure that the annual harvest from the sun is at the maximum it could be. Did I miss anything there, Bev?
You covered everything and more. Approximate percentage difference in efficiency between the panel with the white and the panel with the black background.
It's about 0.5%, not even. It's
Oh, so
usually
it's
it's
minimal.
usually 5 watts, right? What'll happen is I usually call it brother sister panel. There's a black one and there's the black and the white one, right? Usually, like in this case right now, what I have as an offering is a 330 watt panel that is that black and white look. Its complete counterpart, the black version, is 325 watts. That's the only difference. And really what it is you have the same pieces putting it together. You're just artificially derating that panel a little bit because we know that it will run hotter. And that coefficient of it running just a little hotter tends to bring it down a little bit over the course of the year. So it's not
Okay.
drastic. It's not drastic by any means.
Okay. Rodent questions. Is there any issue with creatures in solar panels?
I would be lying if I said no. Yep. And I always ask customers, Is it a current problem? Do we have a rodent problem? Do we have an issue where that red squirrel and its family has just been in this house for the last 5 years, making their home here, doing this, doing that? We want to know that stuff ahead of time, because there are different approaches we can take. The industry has some various little critter guards and stuff that can wrap around the base of your solar panels and kind of eliminate the ability to get in. Birds can be a thing sometimes. We will go out and find a nest here and there. But when you look at it from the big picture for how many projects are installed versus how many have a rodent issue, it's still a small percentage. But the reality is, it is a thing. Usually each spring, there is a few systems that we'll go through. It'll be a maintenance item where a customer calls and we find out that a panel doesn't seem to be producing properly, go out and investigate and find that there's a small nest or something's chewed on a wire. So the reality is yes, it can happen. But for me, that's a big part of my conversation of, as somebody's out looking for solar, it's why you really want to understand who your partner is for your solar project, because you need to have somebody who, when you need them, when you need to make that phone call, they're there. Because you can really get yourself into an issue where, hey, I'm trying to call the company that's unresponsive because, and it's just the normal thing. If you're a small outfit and you're running around trying to stay busy, trying to make the money, you don't have that chance to go back sometimes and maybe, fix or make amends to something that needed to be changed. So that's one of my talking points when I'm kind of educating clients on, who they're making their choice to partner with and what kind of things they want to keep an eye out for in the future. But that's a good one. Rodents do happen.
Okay, great. And I think that's it with our questions, but I do have one, and I'm surprised no one has really asked. And that is, what does New Hampshire have for rebates and incentives at the moment?
Good one, Bev. That's a good one. So historically, the state has offered up a state rebate for solar. Last year, that was capped at $1,000 for a project, maximum per solar install, well, per address. We have since exhausted that fund. It comes from the Renewable Energy Fund, and the Renewable Energy Fund is then supplied through us through our renewable portfolio standards. So that's something that we're putting over the utilities to tell them, hey, you've got to have a certain percentage of your energy produced as clean energy. And if you don't, there's some penalties. And when they pay those penalties, that money gets dropped into a fund that we can now distribute as a solar rebate. As of right now, there is money available, but the state has not completed their budget talks for the year. Budget talks for fiscal year start in July, and we usually have more clarity around that time. So as I've been, just guiding customers now, I do think that we're going to see a rebate become available again towards the end of this summer. If I had to wage a guess, it's probably somewhere between $700 and $1,000 that we'll see become available. But I kind of position that as icing on the cake for most right now. I want to kind of move our sights away from the rebate in terms of just making or breaking the project, right? I want somebody to look at that and say, oh, it would be awesome if I got that, but I don't necessarily need that to make this a choice here. So other than that, you have the ability for the federal tax credit. 26% of the total project cost will come back to you as a tax credit. And I tell all my customers, I cannot be your tax advisor. I'm not legally allowed to be. You need to take this information and go back to your tax pro, your accountant, CPA, and just say, hey, based off of a previous year's tax liability, if I receive the tax credit for X amount of dollars, how does that work for me? How do I receive that? In most cases, most homeowners, we do have that tax liability. We will get the $8,000, $9,000 tax credit. But again, that's this piece that I can't give you a definite on. And I tell you, please go check on that, because and it's happened a few times over the years, the client that doesn't check comes back later on, just really upset that they weren't getting that tax credit. And really it was all on them. So try to just kind of always remind people that's your homework in the process.
Is that a tax credit or a deduction?
Credit.
Wow. Okay.
Yep. So it's a credit. So again, it goes against your taxable liability. So if it's there, you will receive that credit. If it's not, you'll have to roll it over. And what we know right now is the best way to set up that expectation wise is to say, hey, we have a tax credit this year, next year, and then in 2023, that will be the last year of the tax credit. It is reasonable to expect that if you receive a tax credit for an installation this year and you cannot receive the entire amount, that you could then roll that over into the following year, as long as the tax credit is still available as an item there. So that has worked for some. I know a lot of my retirement community, they tend to have a different tax structure at that stage. And sometimes having a nice big chunk doesn't just come back to them in 1 year. Sometimes they have to itemize it over a couple years.
Mhm, mhm. And if people want more information on everything you just explained, would they find that on your website, or is there another site they should go
There
to?
is a ton of information on our website. Please, if you're interested, go check it out. There is a lot more that we go in depth on there. I always direct everybody to our blog. Our blog is a great way to just see really what is going on here in New Hampshire, Maine, Massachusetts for solar. We've got some really amazing projects that we've completed that we like to showcase. We're always kind of talking about what we see coming down the pike, trying to look over that horizon and see what's coming. So lots of information there. People can feel free to email me directly, call Revision directly. If somebody's interested in getting somebody out to review their home, I would say call Revision directly, 679-1777, and talk with one of our solar advisors there. I personally am booked out to about mid-May right now in terms of my visit schedule and my visit time, and most of my colleagues are in much the same. So just to those that are still on, those that are still listening, and might be very excited about getting somebody out, this is the busy time. This is when everybody's calling. So don't be surprised if you have to wait a few weeks to get one of us out to site, but please do, because now's the time. Let's try to get it in this year, capitalize on the sun, and make that clean energy.
Good segue to wrapping this up, because I know you have appointments you need to get to this afternoon, Eric. So again, thanks so much. This has been really informative and great. I just want to remind everybody that I will put all this information in our post session e-communication that will be going out tomorrow. So if you missed the number or Eric's or the Revision's website, I'll make sure that's in your inbox tomorrow. Okay, so thank you very much, Eric, again, and to Revision for being a part of today's program, presenting today's program, and to all of you for joining. Take care. Bye-bye.
Thanks, Beverly. Bye-bye.